Everybody, this is the Algebra 1 polynomial test review. I'm going to try to go through this as quickly as I can. Please take notes, rewind it, pause it as much as you need to. Make sure you understand all the concepts. The first section, we are adding, subtracting, or multiplying, and the key part is you need to show all your work. Okay, so problem number 1, we have two sets of parentheses here, and then we're adding the two polynomials. Hopefully you remember that when you have that in that situation, you really don't need the parentheses at all. You can just get rid of them. We don't need them. Okay, and then at this point, notice that we have a plus sign here. I got rid of the first set of parentheses. I got rid of the second set of parentheses, and then we had a plus and a minus 2w squared, and notice the plus sign just disappeared and I'm just left with a minus 2w squared, and then the plus 8. So anytime you're adding, you do not change any of the signs. Just whatever you see up here in parentheses is what you're going to keep. Okay, at this point, you need to put everything in the correct order, and you need to combine like terms. So the 5w cubed, there's no other term that has there's no other w cubed or raised to the third power, so you're just going to put that first. You don't have to add, subtract, or add or subtract anything to it. And then also the negative 2w squared, that would be your next term, and again there's no other terms that are squared, so we can just write that next. And then the positive 4w that's here, we're going to just write that next. But your negative 10 here and the positive 8 down here can be combined, and if you do negative 10 plus 8, you get negative 2. So you'll have a negative 2 there. That's all you have to do when you're adding two different polynomials. Okay? If you are subtracting your polynomials, you can get rid of the first set of parentheses, don't change anything. But then the second set of parentheses, you're going to have to distribute this negative right here to each and every term. So this negative is going to be multiplied by a cubed, so the a cubed will become negative. It's also going to be multiplied by the negative 2a, so negative times negative 2a is going to be a positive 2a, and then the negative times 3 will become a negative 3. So when you do that, when you distribute the negative through all three of these terms, notice that all three change their sign. So initially this was positive, it's now going to be negative. This was negative, it becomes positive. This was positive, it becomes negative. Okay, now same thing as problem number 1, where you just combine all like terms and put them in the correct order. You're going to do the same thing over here. However, this time you have an a to the third power here, and you also have an a to the third power here. So your positive 4a cubed minus a cubed, remember if you don't have a coefficient, your coefficient is 1. Okay, so 4a cubed minus 1a cubed, you're just subtracting the coefficient, so 4 minus 1 gives you a 3a cubed. Notice the a and the cube did not change at all. And then the next term, we don't have an a squared, but we do have a negative 2a here, and we also have a positive 2a here. Well, negative 2a and positive 2a, they just cancel each other out. So you don't have anything there to worry about. And then your last two terms are a positive 1 here and a negative 3 here. Well, if you do positive 1 minus 3 gives you negative 2. So when you just distribute the negative and combine like terms, this is what we end up with, 3 times a to the third power minus 2. All right, problem number 3, we have two polynomials that we are multiplying together. And we can either do that with the box method or with foiling. I prefer the box method, so I've done most of these types of problems. I've used the box method, but there's a couple that I have foiled. So if you don't like to box, you can go ahead and foil. Just make sure your answers are the same. So we set up the box, and because we have a binomial here, that means two terms, and a binomial here, then we're going to have a box that's has 2 rows and 2 columns. Okay, and notice my first binomial is 4p plus 1. I put the 4p here, the plus 1 here, and then the 4p minus 1, 4p, and minus 1. Now it does not matter which side we put it on, as long as we, if these two are together, they need to be together. When these two are together here, they need to be together. So they can be up here, or they can be on the side, it doesn't matter, but they just need to be paired up. All right, and then when you're boxing, you're multiplying the column by the row. So for this box, we have 4p times 4p, and I just realized I messed up because 4p times 4p is 16p squared, and I might have to fix this down here. And then 1 times 4p is just 4p, and negative 1 times 4p is negative p, and then positive 1 times negative 1, remember you're multiplying, you are not adding or subtracting here, so positive 1 times negative 1 is negative 1. Okay, and then I will probably have to fix that too. Yep, I do have to fix that. Sorry about that, guys. It just shows that Miss Pi does make mistakes sometimes. All right, so we have the 16p squared is on its own, the negative 4p and the positive 4p. When we are combining like terms, we're adding or subtracting. So first, when you fill out the box, you're multiplying, but then when you pull the number terms out of the box, then you're adding or subtracting. So this negative 4p will cancel out the positive 4p. Okay, and then we're just left with 16p squared minus 1. All right, over here, we don't have two polynomials. We have some term that we're multiplying all the other terms by. So we're going to distribute this negative 2 by multiplying it by 8 times m squared. We're also going to multiply the negative 5m times negative 2m, and we're going to multiply the 3 by negative 2m. So when we set that up, initially we're going to have negative 2 times m times 8m squared, negative 2 times 5m, negative 5m, notice I'm putting that in parentheses, and then negative 2m times 3. Okay. Once you get it set up like that, then you need to go ahead and multiply everything out. So negative 2 times 8 will give you negative 16. M times m squared is going to be m to the third power. Hopefully you guys remember that when you're multiplying variables and they have exponents, you're going to add the exponents to each other. Whoops. I don't know how I did that. Hold on. Let's see there we are. Let me go back. So let's see. Yeah. So we're here. Yeah. So we're adding our exponents to each other, and the m, if you have no exponent, your exponent is 1. And so we're going to have m raised to the 1 power times m raised to the 2 power. So that's m raised to the 2 plus 1 power, which gives us m to the third power. All right, and then we have negative 2 times negative 5, which gives us a positive 10. And then m times m gives us m squared. And again, you're just adding the two exponents. So this has an exponent of 1, and this also has an exponent of 1. So you get 1 plus 1 is 2. All right, and then on to our last term, we have negative 2 times m times 3. And so the 2 times 3 gives us negative 6 times m. Okay, let me get rid of all this before I move down. There we go. All right, problems 5, 6, and 7. Problem 5, we are boxing again, or boxing or foiling, and the biggest thing is you need to remember that when you see just one binomial like this that's squared, you can't just distribute the squared to these terms. That doesn't work that way. You cannot do that. Please don't do that. What you need to do is you need to write out the equation. Actually, I think I'm just going to type this because it's easier to type than it is to write it out. Let me see. So this is just equal to, get rid of that. All right, it's equal to 2b plus 3 times 2b plus 3. Okay. Let me move this back over. Sorry, guys. All right. So if you see something like this, you can rewrite it as 2b plus 3 times 2b plus 3. Notice there's nothing different about the binomials. They're the same. Okay, so again, I'm going to box. I'm putting 2b here, plus 3 here, 2b here, plus 3 here. 2b times 2b is 4b squared, and 2b times 3 is 6b. And again, 2b times 3 is 6b, and then 3 times 3 is 9. So when you combine like terms, you'll notice that 4b is going to be on its own, because, 4b squared is on its own because it's the only squared term. And then 9 is going to be on its own because it's the only term with no variable. And then the 6b is going to be added to this 6b. Remember, you are not multiplying, you are adding. And so we're going to have 4b squared plus 12b plus 9. Okay? Another two binomials that we're multiplying together. With this one, I have shown you how to box. I also did it with foiling. And I just want you to remember how to do both and to see that you're going to get the same answer in both. All right, so we have 2r times r gives us 2r squared. 3 times r gives us 3r. Negative 6 times 2r is negative 12. Oh, dang it, I messed up again. Sorry, that's negative 12r. And then negative 6 times 3 will give us negative 18. Okay? When you combine all like terms, we're adding or subtracting. 2r squared's on its own, 18's on its own. You're going to add these two terms together, but because we have a negative 12 here, we'll end up subtracting. Okay, and I probably need to fix my answer up here. Let me see. Yep, I do. So negative 12 plus 3 should be negative 9r, and then negative 18. Okay. And then if you FOIL it, hopefully you guys remember that when you FOIL, you have to multiply the first two terms together, the outside terms together, then the two inside terms together, and then the two outside terms together. So that's where we get FOIL from, the acronym of FOIL. So I'm going to have 2r times negative 6. Oops, sorry, 2r times r, excuse me. And then I'm going to have plus 2r times negative 6. And then I'm going to have 3 times r. And then I'm going to have plus 3 times negative 6. And notice that in between all my multiplying, I'm adding each term here, here, and here. Okay? Once you get that all written out, go ahead and multiply everything together. So 2r times r is 2r squared. 2r times negative 6 is negative 12r. Oh, that's funny that I caught it here but not up here. And then 3 times r is just 3r, and then 3 times negative 6 is negative 18. And notice I did have the plus sign here and a negative sign here, and it just changed it to a minus 18. And then when I combine like terms, I should have 2r squared minus 9r, because the negative 12 plus 3 is negative 9, and then minus 18. All right. So this polynomial, and this is a good example of why I like to box more than I like to FOIL, because if you try to FOIL this one, because you have all three, you have a trinomial here, in other words, a polynomial with 3 terms, and a binomial here, you have to FOIL multiple times. So you're going to FOIL like that, and then you're going to FOIL these terms, and then you're going to FOIL these terms. And as you can see, my picture is getting really, really messy. And so it's much easier just to box it, okay? And by boxing, this time instead of a 2 by 2 square like this, we're going to have a 3 by 2. So my 3h plus 4 is going to be on this side. H squared plus 6h minus 5 is on this side. and I have 3 columns and 2 rows. Now I'm going to go ahead and multiply everything together. So h squared plus 3h is 3h to the 3rd power. And then 6h times 3h is going to be 18h squared. And 3h times negative 5 gives me negative 15h. And 4 times h squared is just 4 times h squared. And 6h times 4 gives me 24h, and that's a positive 24h. And then negative 5 times 4 is going to be negative 20. Okay, cool thing about boxing is you can kind of draw these squiggly diagonal lines, and it really helps you to separate all your like terms. Okay. So 3h to the 3rd power, that's going to be on its own. It doesn't have a like term. And then we're going to have 4h squared plus 18h squared. So that should give us, what, 22h squared? Okay, and then 24h minus 15h, I believe that's going to be 9h. Let's see if I did it right. Yep, it's 9h, and then the negative 20 is just going to be on its own at the very end, minus 20. Okay, hopefully you guys are understanding and you're remembering how to do this because we've multiplied polynomials a lot. All right, let's look at number 8. We have the instructions for number 8 are to find the perimeter of the quadrilateral below. Your answer should be in a simplified polynomial. All right, so for the perimeter, all we're doing is we're adding up all of our sides. So I can't remember which term I start with. Yep, so this side up here, we have 4x squared minus 2x. We're going to add that to our next term, which is 5x squared minus 4. And I know we could put everything in, all of our sides in parentheses, but because we're just adding, we don't need those parentheses. So I'm not going to worry about parentheses. So we have 5x squared plus 4, then we have plus 12x plus 6, and then finally plus 8x. Okay, and at this point, we need to combine all like terms. So our x squared here and our x squared here will need to get added together. And then the negative 2x will be combined with the 12x and the 18x. Notice both the 8x and the 12x are both positive, but the 2x is negative. And then the last two terms, this negative 4 and positive 6 are going to be combined. Okay, make sure you're combining like terms. Like terms mean it has the same variable with the same exponent. And when we combine like terms, we're only adding our coefficients. So for the x terms, we have 4 plus 5, which will give us 9x squared. Notice the x squared stays the same. And then negative 2x plus 12x, that will be 10x, plus 8x will give us an 18x, plus 18x. And then negative 4 plus 6 will give us a positive 2. All right, number 9, they want us to find the area of our rectangle. And then they also want us to simplify the polynomial. So hopefully you remember that for perimeter, you add up all the sides. For the area, you multiply the two sides together. So we're going to have w plus 7 times 2w minus 4. And notice because I'm multiplying, I'm putting them both in parentheses. And with this one, I just showed you foiling. So we're multiplying our two first terms together, our two last terms together, our two inside terms together, and our two outside terms together. You know what? I think I said that backwards. These are the outside terms. These are the two last terms. All right. So again, we're multiplying everything together. I'm just going to show you this. So w times 2w is here, plus w times negative 4 is there, plus 7 times 2w is here, plus, again, make sure you put pluses between each of these. And then the last one is 7 times negative 4 is there. Then we need to go ahead and multiply everything together. So w times 2w is 2w squared. W times negative 4 is negative 4w. And then 7 times 2 is 14w, and 7 times negative 4 is negative 28. Okay, now we need to go ahead and combine like terms. Notice here we don't have any other w squared terms, so that's on its own. This negative 4w and the positive 14w will be combined, and then the negative 28 at the end is on its own. So again, your positive 2w squared is on its own. The minus 28, when you're adding a negative, you can go ahead and just put it as a subtraction, is at the end. And then negative 4w plus 14w is just going to be 10w. Okay, moving on to 10, 11, 12, and 13. With these ones, we want to factor our trinomials, and hopefully you remember how to factor by grouping. And to do this, we need to figure out all the multiples of 2. So for 2, it's just 1 and 2, okay? And we need two terms that multiply together to give our last term and add together to get our middle term. And so when we set this up, your first term is just going to stay y squared, but instead of having this 3y, we're going to do 1y plus 2y, and then we're going to write our last term, which is the positive 2. Now we're going to separate the 4 terms by just drawing a line down here. And we're going to look at these 2 terms and see what we can factor out of the first 2 terms. And both of them have a y in it, so we can factor out a y. And y squared divided by y is just y, and y divided by y is 1. Please don't put a 0 there. Y divided by y is 1. And then these 2 terms we can factor out a 2, and notice the plus sign here, we have to also factor out that sign. So it's going to be plus 2 that we're factoring out, and we're left with y plus 1, because both of these terms have a y plus 1. So we have a y plus 1 here and a y plus 1 here. We are going to have to factor out that y plus 1. And then what's left is this y here and the 2y, and then the plus 2. And so that's our factored form of our trinomial. Over here, we need to multiply this 6 by the negative 12 here. Okay, so we're not looking at factors of 6, we're looking at factors of 72, and that should be a negative 72. I forgot to include that. We want factors of negative 72. So because this is negative here, one of our terms has to be negative, because in order to multiply and get a negative, you need a positive, and a negative will give you a negative. And then because this is negative here, our biggest number needs to be negative. Okay, so factors of 72, we could do 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, or 8 times 9. Okay, and again, because we need a negative, our bigger term is going to be negative. We'll have a negative 9 and a positive 8. And when we add those together, we do get a negative 1 for our middle term. All right, so our terms are going to be, we're going to have our 6k squared first, then the plus 8k, then the minus 9k, and then the negative 12 at the end. And in the first, we're going to separate our 4 terms by grouping them. And the first 2 terms are both even numbers, so we can factor out a 2 and a k, and we're left with 3k plus 4, because 6k squared divided by 2k is 3k, and 8k divided by 2k is 4. Notice the k's cancel out. And then over here, remember this negative in front, we need to go ahead and factor out that negatives. So we're going to factor out that negative, and both of these terms are divisible by 3. So we're going to factor out a negative 3, and we're left with 3k plus 4. And don't forget, negative 12 divided by negative 3 will become a positive 4. So that's how we have our like terms here, this 3k plus 4 and the 3k plus 4. We can go ahead and factor that out. And and so 3k plus 4, and then what we're left with is the 2k here and the minus 3 that we're going to put in parentheses, so 2k minus 3. All right, let's look at 12. So with this one, hopefully you realize that you have something that you can factor out of all three of these terms. Remember up here where it says check for greatest common factor first. You have some number that all three of those terms can be divided by, and that number is a 3. So the first thing you want to do is factor out a 3. So we will end up with 2t squared minus 1t minus 6. When we are factoring out our 3, it simplifies our numbers. Okay, we still need to go ahead and take this 2 that's right here and multiply our negative 6 by it. So when we're trying to get 4 terms like we did up here on problem number 10. But to do that, we need to remember that we're multiplying 2 by negative 6. Okay, so 2 times negative 6 gives us negative 12. So we want two numbers that multiply together to get negative 12, but add together to get negative 1. So we are going to have a negative 1 times 12, 2 times 6, 3 times 4. Those are our options. Okay, and because our middle term needs to be negative, we know that our bigger number needs to be negative. And so positive 3 minus 4 gives us negative 1. And these two terms multiplied together give us negative 12. So let's go ahead and set up our polynomial with 4 terms in it. So remember your 3 is still on the outside. You put your first term there, and then instead of writing minus 1t, we're going to do plus 3t and minus 4t, and then we're just going to put our last term at the end, so minus 6. Okay, now we can go ahead and separate the 4 terms. And we will still have that 3 out front. Don't forget, it's going to stay out front the whole time. It's even, the final answer still has it right out front, see? All right, so now what can we factor out of both of these terms? Well, we can't factor out any numbers, but we can factor out a t. So our 2t squared just becomes 2t, and our 3t becomes 3, because we're factoring out the t there. And then here, our negative 4, we're going to factor out. We cannot factor out a negative 4, but we can factor out a negative 2, because both of these terms are divisible by negative 2. So negative 4 divided by negative 2 is going to give us just a positive 2t, and then negative 6 divided by negative 2 gives us a positive 3. Okay, so here we have our two sets of factors, and both of those factors have the 2t plus 3. So that's going to be our first factored binomial, so 2t plus 3. And then the last one, or what's left, is the t that's here and the negative 2 here. Okay, I don't know why I have those squiggly lines. I'm going to tell it to ignore it. All right. On to number 13. We have negative k squared plus 12k minus 32. Hopefully you guys remember me telling you that anytime you have a negative leading coefficient, to always just factor out the negatives. So all we're doing here is getting rid of our negative sign. And what happens is it changes all of these terms. It changes the sign. So this becomes positive k squared. This becomes negative 12k and a positive 32. We're just changing our signs. So now we need to find multiples of 32. And we have a few options: 1 times 32, 2 times 16, and 4 times 8. The reason why I have the negatives here is because we want two terms that add together to give us a negative number. So anytime you have two negatives and you're multiplying them together, you do get a positive. So despite the fact that this is a plus sign, both of the terms that we need to use will need to be negatives to give us the negative 12. And negative 4 plus negative 8 does give us a negative 12. Okay, and again, the negative that we factored out earlier is going to stay out front the whole time, all the way through the whole process. Do not just ignore that. You have to have that as part of your final answer. All right, so let's look at the rest of this. We're replacing negative 12k with negative 4k and negative 8k. And so we have k squared, which we're just leaving alone, minus 4k, minus 8k, plus 32 at the very end. Now we can separate our four terms into two different sections. And here we have a k that we can factor out. So it would be k times k minus 4. And over here, we're factoring out the negative 8. And we get negative 8 times k minus 4. We now have our k minus 4 is the greatest common factor that we can factor out. And so that will be our first set of parentheses is a k minus 4. And then what's left goes in the second set. So our k here and our minus 8 there is what's in the second set of parentheses. All right, let's move on to problem 14 and 15. Okay, this time we have a rectangle that has an area of 4 times m squared plus 12m plus 8, and we are instructed to factor to determine a polynomial to represent the lengths of the sides of the rectangles. Okay, so guys, all it is we're just factoring this polynomial. We've done it before, and hopefully you've realized that each of these three terms you can factor out you can factor out a 4 because all four terms are divisible by 4. And so that really makes it nice and convenient and simplifies our problem. So now we need two terms that multiply together to get 2 and add together to get 3. There's only one option, 1 times 2. So remember, your 4 is going to stay out front the whole time, all the way through. You've got to keep that 4 out front. Don't just ignore it. And then we're replacing the 3m with 1m plus 2m. And then we're going to group our terms. Okay. And make sure you draw that line down the middle. So in the first two terms, we can factor out an m, and we're left with m plus 1. Remember, m divided by m is not 0. Most of you might make that mistake. M divided by m is 1. And then 2m plus 2 over here, we can factor out a 2. And so we have m plus 1 as greatest common factor for both of these terms. And that's going to be what we factor out first. And then what's left is the m plus 2. So for our problem, we could have a side measurement of 4 times m plus 1, or we could have 4 times m plus 2, or we could also split this 4 up to 2 times 2 and multiply both of them by 2. So that would give us our side measurements. All right, so problem 15, we have a student, Jesse, has factored 10h squared minus 9h minus 9 into this factored form. Is his answer correct? Yes or no? And then how do you know? So the biggest thing is figuring out if he's correct. And to do that, we are going to, sorry for the background noise, somebody's printing. All right, it's done. All right, so to do that, we're going to take our binomials here and multiply them together. I'm going to just use the box method. So I have 10h minus 9 on the top and h minus 1 or plus 1 on the side. Remember, you're multiplying your rows and your columns together. And when you do that, these are the answers we get. Okay, so 10h squared, 10h here, negative 9h, and negative 9. When you combine like terms, so your 10h squared is going to be on its own. 10h minus 9 is, you're going to be subtracting those. And then the negative 9 is on its own again. And so you end up with 10h squared plus h minus 9. So is he correct? The correct answer is no, he's not correct. And the reason why we know is because we multiplied our factored form together, and we do not get the same original equation up here. Notice your middle term is wrong up here. All right, let's look at problems 16, 17, 18, and 19. This one we are factoring polynomials. Hopefully you guys remember that this is a difference of square, because if you have the square root of 60, whoops, hold on, I put it over here. All right, so the square root of 64 is just 8, and anytime you take the square root of a number, it's always positive or negative. Okay, so we're going to have one of our factors is going to have a plus 8, and one of our factors is going to have a minus 8. And so we're just going to have y minus 8 and y plus 8. And that's all we have to do to factor a difference of squares. In order to do a difference of squares, we have to have a minus sign here, squared here, and then this term has to be a perfect square. Okay? For number 17, we're just factoring out what we can. Both of these terms you can factor out a 5. You can also factor out an x squared from the terms. And the reason why we know it's an x squared is because both terms have an x in it, and the lowest exponent is a 2. So we can factor out an x squared. When we do that, we are left with, whoops, I didn't want to do that. Sorry. We are left with this. So 5x to the 5th power divided by 5x squared. This time we're just subtracting this exponent of 5 minus 2 to give us a 3. And then negative 20 divided by 5 is negative 4. X squared divided by x squared is just 1. We don't have to do the 4 times 1. All right, this one, greatest common factor, we do. Hopefully you see that all of the 3 terms can be divided by 3. So we're factoring out a 3. And we end up with x squared minus 6x plus 9. And then we need to know all the 2 combinations of 9. So all the 2 terms that multiply together to get 9, and those are 1 times 9 or 3 times 3. And the reason why we know these are going to be negative is because we have a negative term here. And we are going to use the negative 3 minus 3 or negative 3 plus negative 3 to get negative 6, our middle term. Okay. And remember, your 3's are going to stay, that 3 that we factored out at the beginning has to stay there. Do not ignore it. If you ignore it, your answer's wrong. Okay? You have to have that 3 there. And then let's go ahead and create a polynomial with 4 terms. So instead of this negative 6, we're going to have minus 3x and minus 3x. Notice the x squared and the 9 just stay the same there and there. We can now separate our 4 terms into 2 different groups. In our first group, we can factor out an x. And when we factor out the x, we're left with x minus 3. Our second term, we can factor out a negative 3. And we're left with x minus 3. Okay? So notice what we get is, let me underline that. We have x minus 3 here in parentheses. We also have an x minus 3 here in parentheses. So we can factor that out, and we have x minus 3, and what's left is another x minus 3. Okay, anytime you have a situation like this where this factor and this factor are exactly the same, so same variable, same sign here, we're subtracting both, and same constant term, you can just combine that to be x minus 3 squared. Okay, let's look at problem 19. This one, we have nothing that we can factor out at the beginning, but we do have 4 terms that we can separate into 2 different parts. And the first 2 terms, we can factor out a b squared, and we're left with b plus 3. And the last 2 terms, we can factor out a negative 5, and we're left with b plus 3. And notice both of these terms are the same, so we can factor out the b plus 3 as one of our factors, and what is left is the b squared minus 5. Okay? All right, let's move on to the next set of problems. I think we're almost done. So we have problems 20 through 23, and then we have a couple bonus problems. Let's look at these. Again, we're factoring. For problem 20, we've got 4 terms, so we can separate them. And the first 2 terms, it looks like we can factor out a 5 and a w squared, and we're left with w minus 2. And then the last 2 terms, we can factor out a negative 3, and we've got negative 3 times w minus 2. So we have w minus 2 twice there. We can factor that out, and we're left with 5 times w squared minus 3. And then let's look at number 21. our greatest common factor here, before we do anything else, is we can factor out a 3 times x, because both of these terms are divisible by 3. We both have an x in it. When we factor out the 3x, we're left with x squared minus 9. Hopefully you guys recognize that as a difference of squares, so we need to figure out what the square root of 9 is. We get 3, and again, your answer can be both positive or negative. So when we factor that difference of squares, remember the 3x that we factored out initially still needs to be there, and then we're going to have x minus 3 times x plus 3. Okay, on to 22. There's nothing we can factor out here. We do need to go ahead and multiply the 9 by 4 since our leading coefficient is not 1. And 4 times 9 gives us 36. So we need all the two numbers that multiply together to get 36 and add together to get 12. On 36, our options are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Okay, because this is a plus and this is a plus, both of our terms need to be positive. So we're going to use the 2 6's down here. So the 4y squared is just going to stay the same, but the plus 12y is going to become plus 6y, and then plus 9 at the end. Now we can go ahead, we have 4 terms, we can group those, and we are going to factor out a 4 and a y, or not a 4, but a 2y, excuse me, and we're left with 2y plus 3. Now onto the right side, we can factor out a positive 3. Remember that this plus sign carries down, and then when we do that, we are left with 2y plus 3. So now we have 2y plus 3 on both sides. That's what we're going to factor out. So there's the 2y plus 3. And then what's left is also 2y plus 3. So again, we have the same terms here and here. So we can go ahead and write that as 2y plus 3 and then square on the outside. All right, number 23, I think this is the last one, and then the bonus. We have 4 terms. Let's just split them right down the middle. The first 2 terms, we can factor out a 2 and an x, and we're left with 5y plus 3. And then over here, we're going to have, let me see, there's a lot of different options. Both of them can be divided by 2. They can both be divided by 4. They can both be divided by 8. But we're going to use the 8 because that's the greatest common factor. And so we're dividing both by positive 8. And 40 divided by 8 is 5y. And then 24 divided by 8 is plus 3. So we have 5y plus 3 on both sides. We're factoring that out. And then what's left is the 2x plus 8 there. And then let's quickly go over our bonus question. So this says factor completely. We have 4 terms, and hopefully you notice that all 4 of these terms can have an x in them, so we can factor out an x first. We want to do that first. And what happens, why did I do that? I don't know why I wrote that again. Let's see. There we go. So we're factoring out the x first, and what happens is every single one of the terms, or your exponents, just lose one of their numbers. So 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is just 1, and then 1 minus 1 is 0, so x to the 0 power is 1. So we have this here, and now our next step would be to split this up into 2 groups and factor out our greatest common factors of both groups. So we have the x on the outside, and then first 2 terms we can factor out at x squared, and we're left with x minus 9. And then on the right side, it looks like the only thing we can factor out is a negative 1. So we're going to factor out a negative 1, and all it does is it changes the x to become positive, but it also changes this negative 9 to become positive 9. Now, if you notice, you do not have the same factors. So in order to factor out any more, you would have to have an x minus 9 here and an x minus 9 over here. You do not have the same thing, so you cannot go ahead and factor it in like we normally would when we have 4 terms like we have here. So the only thing that we can factor out completely is the x. So this step that we had, let me get rid of that line. The step that we had up here, we were done. So as soon as we got to this point, we're done. There's nothing else we can do. We tried. We don't get the same terms here and here. So even though this question looks like it would be really difficult, it's really not that hard to factor completely. All we had to do is factor out the x and leave everything else, and just reduce the exponents on everything else. Okay. Just remember, you have to have the same term here and here in order to continue like we have with previous problems. All right, let's look at the next bonus point. Find the area of the shaded region. So we have 2 rectangles, but this is the only shaded region. So what you have to do is you have to figure out the area of the bigger rectangle and the area of the smaller rectangle and subtract the area of the smaller rectangle, and that will tell you the area of this shaded section. Okay, so what you have to do is find the 2 areas. So you're going to have 2x plus 3 times 4x minus 5, and then you're also going to have the 3x plus 2 times x minus 8, because to find area you have to multiply those together. Okay, I think I foiled everything. Let me check. Yeah, I just foiled everything, and I didn't even show all the steps, because hopefully by now you remember how to foil and you know how to do this very easily and very well. So I just foiled all my terms here, foil all the terms here, and then, whoops, pretend that's a straight line. All right, foil everything, and then this is what you get. Notice my first set of parentheses here, I just dropped all the parentheses and wrote everything out. But because I have this negative out front, I'm going to leave the second set of binomials in a set of parentheses because I have to distribute this negative throughout. Okay, so a couple things from this step to this step, you can combine like terms. So this middle term here can combine, the middle terms here can combine. So we're left with this situation here. So the negative 10x plus 12x gives us positive 2x. And then the negative 24x plus 2x gives us negative 22x. And then now that we have this, now we need to go, sorry, this is all simplified. Now we need to distribute the negative throughout. So we're just going to multiply all these by -1, which all that does is it changes all the signs. So the positive 3x squared becomes negative 3x squared. The negative 22x is positive 22x, and the negative 16 is positive 16. We've now been able to get rid of our last set of parentheses, and now we can combine like terms. So this positive 8x squared and the minus 3x squared will be combined. Let me change my color. The 2x here, the 22x here, and the 16x will also be combined. And then we just have our negative 15 is kind of lonely. It's all on its own. Oh, wait. Whoops. I messed up when I told you the combining the 16. Okay, so the 16 at the end here and the negative 15 here will get combined. When we combine all that, 8x squared minus 3x squared gives us a 5x squared. 2x plus 22x gives us a 24x, and then 16 minus 15 gives us a positive 1. All right, so that's the end of the video. At least half of these problems are going to be on your test. So I really hope you watch and take notes and pay attention and make sure you understand how to solve all these problems. I would love for more of you guys to do the bonus questions than what I've had in the past. So please pay attention. Make sure you know how to do this. All right, good luck. Watch it as many times as you need to.